All right, so the first set of notes. You should have just completed the Desmos activity. So this was the chart that you were filling in, and you have all of those pieces filled in. And we're going to look specifically at that activity to help us with these notes here. Okay, so based on the activity you just completed, we're going to explain patterns that we observe by filling in the blanks. Now, before we do that, I want to talk to you about two forms that we've seen. Well, one form that we've seen and a new form. So first of all, for quadratic equations, we have dealt a lot with standard form. Okay, and standard form is y equals ax squared plus bx plus c. So since the beginning of the semester, we have dealt in standard form. Our new form is going to be vertex form. And that's really what we're graphing in. We're going to look at bits and pieces of it here, and then finish off with it in the next set of notes. So vertex form is y equals a. Now remember, a tells us what happens to our graph if it gets skinnier or wide, or we have a compression or a stretch. And then we have x minus h squared plus k. And we're going to learn what all of these values mean. Okay. All right, so let's see. When a quadratic equation is in the form y equals x squared plus k, where k is this constant, describe the translation. So if you go back to your Desmos activity, that was all of these equations, right? Y equals x squared, and then we had a plus or minus k, plus or minus a constant term. Okay, so when k was greater than 0, the parent function translated or shifted which direction? So let's go back, and we did one of those together, and hopefully you filled in the other ones. But when k was greater than 0, so when it was a plus 2, what happened? My graph shifted up. Okay, so my graph shifts up from there. Again, if you can print this, I highly recommend you do so. If not, you might have to do some pausing to be able to write everything out. Okay, but my graph's going to shift up if k is greater than 0. Now, what happened when k was less than 0? What happened to the parent function? So if I look here, we did this one together where k was less than 0, right? It was a minus 3, and my graph shifted down. So if k is less than 0, my graph's going to shift down from that parent function. Now, when you had a quadratic equation in the form of y equals quantity x minus h squared, where h is a constant, what happened? So that was all of the equations down on the bottom half of your Desmos activity, right? Your quantity squared. So what happened? When h is greater than 0. So, we didn't do one of those. So let's kind of go through. Let's see if you did the second one right? Because h is greater than 0 in this case. So my vertex here ends up being -4, 0. This should match what you have on your paper, -4, 0. I still had a minimum value. My axis of symmetry is x equals the x value of my vertex, which is -4. My range, because it's a minimum, everything increases, so y is greater than or equal to the y value, which is 0. And now here's where things change. Your shift should have been a shift left 4. So hopefully you notice that from your parent function, this new one shifted left 4. My a value is 1, so there is no change to the actual shape of the graph. Okay, so that's what you should have on your paper for that next column. That next row. So if we come back to the question that we're being asked, if h is greater than 0, the parent function translates which direction? So here's h greater than 0, but it shifted to the left. Okay, so my graph shifts to the left. If h is less than 0, what happens. So both of these, h was less than 0, and in both cases, they shifted to the right. They shift to the right. So you'll notice that for k, the shift correlates to what happens. If it's greater, it goes up. If it's less, that it goes down, right? It stays the same, whatever direction it's telling you to go. This one is opposite. If it's greater, you would think it would go to the right, but instead it went to the left. This one, when it's less than, it goes to the right. So these ones are opposite. So something to think about. These are going to be the same. And when I say same, greater than up, less than down, right? And these ones are opposite. If it's greater than, it actually shifts to the left. If it's less than 0, it shifts to the right. So something to think about. All right, let's look at key features. So what determines if the graph becomes skinny or wide, or whether you have a stretch or compression? Okay, what happens, or what determines whether you have a stretch or compression? And if you remember from last week's notes, the A value will change. So if A is between 0 and 1, you are going to have a compression. It's going to get wider. If A is greater than 1, we're going to have a stretch, and our graph is going to be skinnier than our parent function. Let's see. Blank determines if the parabola opens up or down. So the orientation. What determines if it opens up or down? That A value again. If A is positive, so if you have a positive A, your graph's gonna open up. If you have a negative A, your graph's gonna open down. Okay, so that A value still determines whether it opens up or down. Now, when you're determining compression or stretch, you just look at A. Don't worry about if it's positive or negative. You just are looking at the number. The positive and negative, you deal with the orientation, so whether it opens up or down. Okay. Now, blank and blank determine the vertex. This is the new piece of information. But if we go back to our activity here, you should notice, remember we said all of these values stayed the same, right? They didn't change. They either went up or down. So here, -3 told me it went down. Well, isn't that also the y value of your vertex? Isn't 2 the y value of your vertex? I can tell you your vertex for this one is 0, 1. Is 1 the y value of your vertex? This one here, your vertex is 0, 4. Okay, it's the y value of your vertex. So k is going to be the y value of the vertex, and it's going to stay the same. So whatever you see, right? So I see -3, it stays -3. I see 1, it stays 1. I see -5, it stays -5. Okay, it's going to be the same. Now, on all of these, I had a -2, and it became a +2 for the x value. I had a +4, and it became a -4. I had a -1, it became a +1. I can tell you this vertex is 7, 0. So it was negative, it became positive. So h is the x value of my vertex, and this is always going to be opposite of what you see. Okay, it's always going to be opposite. And our axis of symmetry in vertex form is determined by that h, right? Because that's the x value of my vertex. So the x value of the vertex. All right, that was a lot of key features. All of these things are going to be important, but the really nice part about graphing quadratic equations is you can identify every single key feature without actually having to graph. Okay, so like when I came back here and I said, you know, here's what the vertex is, I can fill in all of this without actually looking at the graph because of vertex form and identifying those key features. It's a good check for you as we go through. Okay, so let's take some time and actually graph. Now we're going to continue to create a table of values, but you'll notice here I don't give them to you. So in the last unit we gave you a table of values. From here on out you're creating your own. Okay, so I want everyone to draw a table, and we're going to label our table of values XY. Now the first thing you are going to do before you do anything else is you are going to determine your vertex. Okay, you're going to determine your vertex. Now, for reference, x squared minus 2 is going to look similar to all of these, right? So you'll notice I don't have the parentheses, which means my x value doesn't change. And all of these, my x value is 0 because there's no parentheses. My y value, however, is what's added or subtracted at the end. So here, again, no parentheses, so the x value of my vertex is going to be 0. Okay, there's no parentheses, so my x value is 0. What's added or subtracted at the end is going to be my y value. And remember, the y value, all of these stay the same. So since I have a -2, my y value is -2. Okay, my vertex is 0, -2. Now I'm going to place my vertex in the center of my table, and if you remember from last week's notes, all of them, the vertex was in the center and then there was symmetry on either side. So if we put the vertex in the center and we choose numbers above and below that are the same, or that are equal distant away from the vertex, we'll have symmetry for y. So we're going to choose two numbers directly below 0, and we're going to choose two numbers directly above 0. So two numbers above 0 would be 1 and 2. Right? And two numbers below are going to be -1 and -2. Now, if we do this right, we're going to have some symmetry. So let's plug some things in. So let's plug in 1. So if I plug in 1, and let me actually get a scratch piece of paper. So I'm using y equals x squared minus 2, and I'm going to plug in 1. So y equals 1 squared minus 2. 1 squared is 1 minus 2 gives me a -1. Okay, so this value here is -1. Now, because of symmetry, this one should also be -1, but let's check. Okay, so if I plug in -1, -1 squared is 1 minus 2 gives me -1. So once you've identified your vertex, and if you choose your points correctly, you don't have to plug everything in. Okay, you can use symmetry to help you. So I'm going to plug in 2. Y equals 2 squared minus 2. 2 squared is 4 minus 2 gives me 2. Okay, so this is 2. And again, because of symmetry, I don't even have to plug that in. I know that's going to be a 2. Now remember how I said before I graph I can fill in all this information? Which I can. So let's do the axis of symmetry, right? Axis of symmetry is x equals, and it's always the x value of your vertex. So if the x value of your vertex is 0, it's x equals 0. Okay. What direction is my graph going to face before I even graph it? What direction is it going to face? So remember, if A is positive, it opens up. If A is negative, it opens down. Here, A is a +1, which means my orientation is going to be up. If you graph this problem and it doesn't face up, then you graphed it wrong, or you found points that were incorrect. Okay, so my graph should face up. The scaling's a little odd on this, so you'll notice that every 2 boxes is 1, so our graph's going to probably look a little funky and not quite normal, but there really is no change to our graph because A is a 1, so there's no change shape-wise. It's not a compression or a stretch, it's just because of the scaling. I'm going to wait for domain and range, but let's plot our points, and again, watch the scaling on this. Actually, let's just change the scaling so it doesn't look funky. So instead of using the scaling that's on here, we're going to just do 1, 2, 3, 4, 5, and so on. Okay, so negative 2, 2 is a point. Negative 1 is a point. 0, negative 2. 1, negative 1. And 2, 2. Okay, so I'm not using the scaling that's on that graph just because I want it to look normal. If not, it's going to look wider than it's supposed to be. And I don't want to confuse everyone. Let me highlight that a little bit so we can see it better. That's better. Okay, so there's my graph. It faces up, which is good. It looks normal, which is good. The domain of the graph is always all real numbers. Now the range I have to think about. So I have a low point, which means I have a minimum, right? So I have a minimum. And everything's increasing. So y is greater than or equal to, because it all gets larger. And it's going to be y is greater than or equal to my lowest point, which is the y value of my vertex, which is negative 2. So math-wise, there's not a ton other than filling in the table of values. That's only like true math you're doing. Everything else is key features and understanding those key features as you go through them. Okay. All right, let's look at the next one. So this one, I have x plus 3 squared. This is going to look more like these ones, right? So this now is my h value. And what happens with h? It's opposite of what I see. Okay, and remember h is the x value of my vertex. So if it's opposite, my vertex is at negative 3, because I take the opposite of what I see. It's positive, so I'm going to go negative. Do I have anything added or subtracted here? No, which means my y value is 0. Okay, that's going to be my vertex. So opposite if it's inside the parentheses, the same if it's outside the parentheses. And we're going to create a table of values. And just like before, we want our vertex to be in the middle, so we have to do less work, okay, right? Because I know that you all don't enjoy doing all the work. So let's make our lives easy. Now, again, when we're choosing, we have to make sure we choose the appropriate numbers. So 2 numbers that are less than negative 3 and 2 numbers that are greater than negative 3. So I'm going to start with greater than. 2 numbers greater than negative 3 are negative 2 and negative 1. 2 numbers less than negative 3 would be negative 4 and negative 5. Okay? And we're going to plug those values in. So let's plug in negative 2. So I have y equals x plus 3 squared, and I'm going to plug in negative 2. So negative 2 plus 3 is 1. And 1 squared is 1. And because of symmetry and because I chose my points appropriately, this one's also going to be 1. If you don't believe me, plug in negative 4, and I promise you're going to get 1. Okay, let's plug in that negative 1. So y equals negative 1 plus 3 squared, which is negative 1 plus 3 is 2. And 2 squared gives me 4. So that value is 4, and so is this value because of symmetry. Okay. Again, we're not going to use the scaling because I think this is going every 2 boxes is 1. So we're just going to do 1, 2, 3, 4, 5, and so on so that it looks normal. So let's plot those points. So negative 5, 1, 2, 3, 4, 5, and I'm going to go up 4, 1, 2, 3, 4. Is my first point. And then negative 4, positive 1, negative 3, 0, negative 2, 1, and negative 1, 4. So when I graph this, again, there should be symmetry. Here's my graph. I'm going to just highlight it so y'all can see it better. Now my orientation, right, my A up here is 1. So my graph should face up because it's a positive 1, which it does. So that's awesome. Because A is 1, there's no change. It's not skinnier. It's not wider. There's no compression or stretch. Axis of symmetry. X equals always, and it's the X value of your vertex. The X value of your vertex is -3. The domain for all of these functions is going to be all real numbers. The range, okay, so again, we have a low point, so I have a minimum. And based off the fact that it's a minimum, everything increases, so its y is greater than or equal to, and it's the y value of my vertex. That's the lowest point I can go, right? That's the lowest I go on my graph is at 0. Everything else is larger than that. Okay. All right. Now this last one combines both of them, right? This one looks more like vertex form. I have an H value, which is inside the parentheses. I have an K value, which is outside the parentheses. Now, remember, H is your X value. K is your Y value. And this is for your vertex. So H is the X value, K is the Y value. H is opposite of what you see, K is the same, okay? So if I take my vertex, H is a 3, but it's going to be a -3. And here's why. Look at, if I go back up to this equation here, it's X minus H. Now if I plug in a -3, negative times -3, doesn't that give me a +3? So the reason it's opposite is because of that negative in the equation. Okay, the equation here is positive. Now it's exactly what you see. It's the same, so it's -2. And if I plugged in -2, it would still give me a -2. Okay, so if it's in parentheses, we're going to take the opposite. If it's outside the parentheses and a constant, it's going to be the same. So my vertex is at -3, -2, and I'm going to place that directly in the middle of my table. Now again, I want to find two numbers that are smaller than -3 and two numbers greater than -3. So -2, -1, -4, -5. And I really only have to plug in two of them. So let's plug in -2. Yep, okay, so let's plug in -2. -2 plus 3 squared minus 2. -2 plus 3 is 1. 1 squared is 1. Minus 2 is a -1. Okay, so I have a -1 here. And again, because of symmetry, I'm also going to have a -1 there. And let's plug in -1. -1 plus 3 squared minus 2. -1 plus 3 is 2. 2 squared is 4, and 4 minus 2 gives me 2. 4 minus 2 gives me 2. So I have 2 and 2. Okay. Before I graph, let's see what it's going to look like. So out front would be my A value, right? If I look at vertex form, A is in front of the parentheses. There's nothing there, which means A is equal to 1. Because A is positive, my graph should face up when I graph it. If it doesn't, I did something wrong. Because A is 1, there is no compression or stretch. It's going to be like my parent function. All right, so let's plot those points. So again, don't worry about the scaling. We're just going to use each box equals 1. So -5, 2 is my first point. -4, -1 is my next point. -3, -2, -2, -1, and -1, 2. Okay. So my graph faces up, it looks normal, it's not skinny or wider, so that's good. I probably did those points correctly. So those are things that I want you to ask yourself as you go through these. Axis of symmetry is always x equals, and it's the x value of your vertex. Domain for all of these is always all real numbers. Range, again, I have a minimum. So everything is going to increase. So y is greater than or equal to. And again, it's always the y value of your vertex. And in this case, my lowest point is at -2. Okay, before you do the next set of notes, I would recommend that you do the assignment that goes with this set to practice, because the next set is going to be all functions that are in vertex form with h's and k's.